Hello everyone, welcome to Pseudocoder. This is Ravina. Today we are going to talk about what is time complexity, what is space complexity, and how to calculate those. Okay, so let's get started. The time complexity is actually the total amount of time that is needed for an algorithm to complete its execution. So, for example, each algorithm will have some operations to run, and there is some time needed for those operations for each operation to complete its execution. And if you combine them all, that is going to be the time complexity of the algorithm. Whereas the space complexity is actually how much space that the algorithm needs in order to complete its execution. So, for example, if you use an array, if you use variables, how many variables you use, all that constitutes to the space that the algorithm is using, and that is actually called the space complexity. Now, I have a few examples to explain it better. So, let's start. So first, I have the count. The count is initialized to 0. I have n that is initialized to 5. And then I have a for loop starting from 0 to n minus 1. I have a count. I'm incrementing this count every time the for loop is getting executed. And I'm printing out that count. I'm also printing out I just for understanding it better. So let me execute it. Okay, so if you look at this, this is the first loop. The count becomes 1 when I is 0. Since range works from 0 to n minus 1, that's why you have I equal to 0. Now you have count 2 when I is 1, you have count 3 when I is 2, count 4 and count 5 when I is 4. So this particular for loop is getting executed how many times? It's getting executed 5 times. And why is that? Because you have a for loop from 0 to n minus 1. That means from 0 to 5, that is actually 5. So, um, sorry, it's from 0 to 4, that is actually 5. So, the time complexity of this particular for loop is going to be O of n because it is getting executed n times. And how did I get n? Because now I have n as 5, it was executed 5 times. Now, let me show you something. If I change this n to 7 and execute it again, you'll see that this particular for loop is executed 7 times and the count actually becomes 7. So this for the time complexity of this for loop is directly dependent on what? It is dependent on n. And however the n changes, this is going to execute those many times. And that's why the time complexity of it becomes O of n. O is the big O notation, that is the upper bound. You can learn about it. You can Google it. What are the three types of complexities that you have? And you'll understand that this complexity is going to be O of n. Now let's talk about the second example. Let me clear this off. Yeah. So the second example, in my second example, I have a count which is again 0. I have n which is 2. Now I have a for loop which has I index going from 0 to n minus 1. And then I have another for loop inside that for loop that has a pointer j. Now I'm printing I and j, and then I'm incrementing my count and printing out my count. So if you look at it, my I is getting executed once, and then my j loop is going to execute till the end of the number. Then my I is going to increment and my j is going to be executing again. So let me run this to show it to you. Okay, so if you look at the second loop, your my I and j is 0, my count is 1 because it was executed once. Again, my I stayed 0, but my j became 1 since this for loop is inside the other for loop. My count is 2. My I becomes 1, j is 0, count becomes 3, and then I and j are 1 and count becomes 4. So in the second for loop, you'll see that it was executed 4 times. Now, how did that 4 come in? So it actually depends on n. So whatever this n is here versus this n. So it's going to be n into n, which is n square. Suppose if I change this to say 3 and I rerun the code, you'll see that in the second loop, my count actually becomes 9. And that is 3 square. 3 square is 9. And so it becomes 9. If you had a scenario where you have two for loops, this is something different and this is something different, then your time complexity would be that number into that number. So for example, if this is 3 and this is 2, and if I run it, so 3 into 2 is how much? It's 6. And if you look at the second loop, my count is 6. So the time complexity is actually whatever the for loop and what is the upper bound of that for loop. You multiply them together, and that is going to be your time complexity for nested for loops. Okay, so let's talk about this last example that I have for time complexity. I have a count which is 0 again. I have n which is 6, and I have I ranging from I which is ranging from 0 to n. And look at this. This is really important. Every time I'm dividing my n by 2. Every time I'm going through the loop, I'm dividing my n by 2. That means whatever my n is, it is getting sliced into half every time the for loop is executing. And what happens then? If you look at it, the count was initially 1 when my I was 0. Since my n was cut into half, my I then actually becomes 3, and my count is becomes 2, and this actually stops, right? So since my n is drastically, getting cut down into half each and every time, the time complexity of this particular code is going to be log of n. And if you look, log of 6 is going to be 2. So that's how you do it. That's why when we do binary search, we have an array with us. We take the middle part. We look for things on the left and right hand side. We sort the array and look for integers on right or left side, and we move on to that side. And that's how our time complexity actually becomes log of n. So binary search is log of n, and this is the actual explanation for it. Okay, so this is how the time complexity works. You'll come across situations where, you will have, say, two loops. Suppose you have two for loops, one for loop from 0 to n, and the other for loop from 0 to n. They are not nested, they are just next to each other, like one after the other, sorry. So what happens then? Then the time complexity is actually n plus n, and n plus n is what? 2n, right? And when calculating time complexity or space complexity, uh, if you substitute n with infinity, so let's think, 2 into infinity, how much is it going to be? Is it going to affect it? I don't think so. So that's why we drop those constants. So when you calculate time or space complexities and you come across constant like plus one, or any constant, or you have n square plus n, then you actually drop n. So that's how you do time complexities. Now let's talk about space complexities. Now I have this simple example here for space complexity. I have a nums list. I have n, which is initialized to 5. I have a for loop, and then I'm appending nums, I to that nums every time I'm executing that for loop. Now, initially my nums had 0 length, and my n is constant, which holds number 5. When I run this for loop and I append it, in the end, the nums array becomes this. It becomes 0, 1, 2, 3, 4. And the length of that nums array is actually 5. Okay, so how much space did I take this time? My nums is actually of length 5, and this is my constant. So 5 plus 1, right? Now, where did that 5 come from? Since my for loop is executing 5 times, and that is dependent on n. So simple change I'm going to do, I'm going to make it 7. Let's see. Okay, so my nums array changes, the length of my nums changes. So the length of the nums array is directly dependent on what? On n. So the space complexity is really O of n plus this small constant here, O of 1. And since we just talked about it, we drop the constants because that doesn't make any much difference. So that's why the space complexity of this one is going to be O of n. Now, this is really important thing. You might have seen me calculating space and time complexity at the end of every algorithm problem that I solve. And I highly encourage you guys that you also do the same, because when you start solving problems and you start calculating time and space complexities, as you move on to much harder problems, you will be able to calculate them really easily, right? So if you try to do them from the start, please do calculate the space and time complexity of every algorithm that you solve. That will give you an idea of what you're doing, how efficient your algorithm is, and how you can make it better. I hope this video was helpful, and give it a thumbs up or comment below if if you like this video. If you have any new requests for me, please let me know in the comment below. I'm on Discord, so feel free to join the Discord channel and chat with me. And I will see you next time. Have a nice day. Bye.